So far, we have been testing small programs, for example, the Roman numeral, the blackjack, and each of these programs had their specific test suites. So we had the Roman numeral test class, the blackjack test class, and etc. But in a larger system, it changes a bit, because you still have many classes, but they somehow work together. For example, class A might collaborate with class B and with class C. But we still want to test these classes in isolation, meaning if you have class A, then you have lots of tests that exercise A and make sure that A doesn't have bugs. And this goes to an A test class, for example. And if you have class B in your system, then you're going to test B in isolation, and then you're going to test C in isolation, and etc. Throughout this week, we will learn how to test classes that depend on other classes. But the main goal is still to have every class that we have in our system, we will have a dedicated test to that class. And if you take this approach, this is what we call unit testing, meaning we are testing one unit of our system, but isolated from the rest of the system. And this is a very common approach that we usually take when testing systems. But this gives us a question, and the question is, what is a unit? Or what do I mean by unit? If we see some definitions, and the first one I'm going to show is the definition from the ISQTB book. When it goes to unit testing, the book says, unit tests search for defects in and verifies the functioning of software items. For example, modules, programs, objects, classes, etc., that are separately testable. So again, a unit doesn't have to be a class or just a method. It has to be something that is separately testable. If we go to another definition, for example, the one from Roy Osherov, he says a unit test is an automated piece of code that invokes a unit of work in the system. And a unit of work can span a single method, a whole class, or multiple classes working together to achieve one single logical purpose that can be verified. So, pragmatically speaking, this means that as much as possible, our classes will be very cohesive, and we will be able to test just that class in isolation. But sometimes we need more than one class to test the whole behavior that we want. And then we will put these classes together. But now that we know what unit test means, we need to discuss the advantages and the disadvantages, right? Because as with any software testing practice, you have both. And for unit tests, the advantages are that they are very fast. You have been running lots of unit tests so far, and you see that they just take a few milliseconds to run. And this is very nice and very useful because this means you can test a huge amount of your software in a few seconds. It is also very easy to control. And by controlling, I mean usually what you do is you pass parameters to a method and you control these parameters. You can pass different parameters and this is quite easy. And then the method or the class gives you an output and then you can do assertions on this output. And so you have lots of control. But a disadvantage is that these tests are less real. In real life, your software is not just about one class, but about many classes working together. So in a way, unit tests are far from reality. The second disadvantage is that some bugs cannot be reproduced at this level. Some of them just happen when everything is put together, right? Think about a web application. Some bugs only appear when you have HTML and JavaScript in your server-side application all working together. So, well, can we tackle these disadvantages? And in other words, can we make our tests to be closer to reality? We can. We just don't call it unit tests. We call it system tests. And the ideal of system testing is that instead of testing just one class in isolation, we test our whole system working together. And I put a black box in there because sometimes we call this kind of test black box testing. Because now you don't know the source code anymore, meaning we just see our software running. If it's a web application, we see the software by means of a browser. And that's how we do system tests. We want to exercise everything, your server side, your database if you have one, your web service if you have one, etc., etc., etc. And of course, the advantage of this kind of tests are that they are very realistic. They capture the perspective of the final user. But a disadvantage is that these tests are usually very slow, because now it's not about only running one class, but running the whole system. And this means, again, having a database, web services, and etc. And this is just slower. They are also hard to write. We're going to see through the course that if you have a database, you need to set up the database. You have to set up the schema. So this means more code if you want to automate the tests. And again, these kind of tests tend to be flaky. And by flaky, I mean you run the test, it passes, you run it again, and it fails. And we don't usually like this kind of tests. We will discuss more about flaky tests in the future. But so far in this video, what I want you to get is we have different test levels, as we call, and I just introduce you to unit testing, which is we want to test a unit in isolation. And the other side of the idea, which is system tests, and we are testing the whole system there. In this first course, we will focus a lot on unit tests and the interaction between these units, because we see lots of advantages on that. But as you can see, all the levels are important as they give us different perspectives. We'll get there.